Dear students, let me welcome you to our session on Sampling Design 1. We have identified the learning outcomes that we expect from you. So after going through this session, you should be able to discuss the basic concepts of sampling, be able to distinguish between a sample and census, differentiate between sampling and non-sampling errors, and explain the meaning of sampling design. You should also be able to classify and describe the different types of sampling design and explain when each of these can be applied. In this session, we'll only be talking about probabilistic sampling designs. Okay, last two sessions that I took for you, we had taken the context of a caselet where we had a organic vegetable grower, Mohan, and his apparent lack of success in organic vegetable farming venture. So we had identified some research questions, we had looked at research design types, where we looked at exploratory research and conditions to select what is it that will allow him to choose a particular kind of research design. Therefore, using the same caselet, we will try to discuss the options to apply the various sampling design so that Mohan can conduct, with your help, his marketing research. Before we go into the theory of selecting sampling designs, let us look at some of the basic concepts relevant to sampling. The first concept that we need to understand is what is a population. We draw a sample from a population. So the population refers to any group, people or objects that form the subject matter of the study. In this case, since Mohan is wanting to conduct his research study on his consumers, the consumer groups in that entire locality or that market would be his population. One single member of that population would constitute the element of the study. That means a single consumer, therefore, would be the element for the study. The next term is sampling frame, which comprises all the elements of the population with proper identification, who are then available to the researcher at any stage of sampling. So the total number of consumers that he will be using for his study, from which he will be ultimately selecting his sample, are called the sampling frame. A sample, on the other hand, is a subset of the total population, because he would not be studying the entire population. He'll be drawing some people out of that population and studying that. So this subset of the population is called a sample. One single element of that sample will be called the sampling unit. A census study, on the other hand, is an examination of each and every unit of the population. So if he studies every single consumer in his total population, this would be called a census study. The sampling design is the process of selecting a sample from a given population. When you select samples, there possibly, or when you conduct a study using a sample, there can be possibly two types of errors. One is a sampling error, which occurs when you do not select a sample that can give you representative results, where the sample mean and the population mean are different. Therefore, the sample is not representative of the population and is not an apt description of the population. Those errors that arise out of this kind of sample drawing are called sampling errors. The research could also have errors other than sampling errors. For example, people do not give proper responses. The questionnaire design is not proper, therefore it is not eliciting the information that is required to fulfill your research objectives. So those are called non-sampling errors. Now, why do we need to use sampling at all? Studying the entire population could be very time consuming and could also involve a lot of expenditure. Therefore, selecting a sample, studying a sample which can represent a population, enables the collection of a data in a very cost-effective and timely manner, also a manageable manner. At the same time, you can continue to maintain accuracy and precision. If you are using a proper sampling technique, it ensures that the sample is representative of the population. Therefore, the results that you get out of that research are actually generalizable and reliable. So we've quickly summed up the using samples. One is cost and time efficiencies, the other is feasibility. May not be feasible to study the entire population. Accuracy and precision, because the data is manageable and you can control the data quality that you gather from a sample. It's possible also to test, do a pilot test, validate your instruments, validate your information collecting tools, and therefore move ahead with properly tested instruments, properly tested and validated data. It also enables you, if you've taken a representative sample, it also enables you to study the variability within the sample and the similarity. So the extent to which heterogeneity exists and homogeneity exists can also be studied through a sample, properly chosen sample design. We began this session as a sampling design 1. So let's look at what are the different kind of sampling designs that can be applied. Broadly, there are 2 categories, the non-probability sampling design and the probability-based sampling design. The probability-based sampling designs ensure that each and every member of the sample has got a known probability of being included in the sample. Non-probability design, there is no known probability of members of the population being included into the sample. So each one of them has several categories. The probability sampling design include simple random sampling, systematic sampling, stratified sampling, and cluster sampling, or a combination of some of those. The non-probability designs, on the other hand, are convenience sampling, judgment sampling, quota sampling, and snowball sampling. During these sessions that we are handling, we will be studying each one of these designs. Okay, this particular session I'm limiting to probability sampling design and the probability designs, and we would be the simple elements that define probability design is that every member of the sample has got a known chance of being included into the sample. But look at the lowest bullet there. Known does not mean equal. There are only certain cases of probability samples which ensure an equal and known chance. We'll come to that when we talk about a simple random sample. That's where we are. We look at the special case of every person has a known and an equal chance. Probability designs are actually used in conclusive research. And as I said, each and every element has a known chance of being included in the sample. So these are the main types. I've tried to give you a diagrammatic representation of simple random sample, a systematic sample, a stratified sample, and a cluster sample. As we go through the description, it will be easier for you to realize the significance of these figures. A simple random sample is one where, and this is a straightforward random sampling instance where every element of the population has got a known chance and an equal chance of being selected. So not only is the chance known, but the chance is equal for every member. So anybody can actually get selected in a random sample, and this is an equal chance, equally distributed throughout the population. How do you implement a random sample? We obtain a comprehensive list of all potential customers in Mohan's area. Let's say Mohan is doing this work in the city where he's marketing his products. So we have a comprehensive list of every customer in that area. We can do that in several ways. We can collaborate with local organizations and have an access to customer databases and utilize those. We can purchase a customer list from a reputable marketing research firm, or we can use publicly available demographic data depending upon the kind of regulation that exists about sharing of that data. Then we use a random number generator which are publicly available. Some of them are open source and free. So you can use these random number generators to yield a statistically significant sample size. We will be talking about how to calculate a sample size later, but let's say Mohana decided that in the first instance he'll be selecting a sample of 500 people out of this total population of 5 lakh. Then he uses the random number generator to yield this sample size by using these random numbers. And once you've selected the sample size, you use your chosen data collection method to get the primary data. He could use a questionnaire, he could use a Google form or a survey monkey to get the answers that he's seeking for his research question. Advantages of simple random sampling are many. One, that is a very straightforward method to implement. The results are always statistically unbiased if the sampling frame accurately reflects the population. So if you accurately use the sampling frame, then your results would always be unbiased and representative of the overall population. However, the disadvantage is that when you're drawing up a list, population list, a very complete and representative list can be sometimes challenging, especially if it's a small businessman who's trying to get that. If he's using official databases, some of the people from the time that the data was developed may have left, other people may have joined. So this drawing up a complete, accurate, comprehensive list may sometimes be challenging. The second method of probabilistic sampling is systematic sampling, where which addresses the concern that a simple random sample may not be representative. So what we do here is that using the elements of the population, arrange the entire population either in an ascending or a descending order. Then we decide upon a sampling interval, which is a ratio of the size of the population to the size of the sample, and whatever number we get, so K is your sampling interval, you take the total population size and you divide it by the total desired sample size, we get a figure which is the sampling interval. If it has to be rounded off to an integer, suppose in this case your integer that you work out is 3. Now any random number from 1 to K, the total population from 1 to K can be selected, and let us assume that number is 2. So your first customer on your list will be, let's say if it is the second one, and then we go on and so on. So the second number would be 2 K plus 2 into 3. So that would be your first second number, and then so the next would be K plus 3 into 3, K plus, and so on. We go on till we get the desired number of our sample size. Now, advantages of systematic sampling are that it is simple to administer, it is statistically efficient, and it can completely represent your population. However, the extra effort that you need to draw up the list, arrange it into ascending, descending, working out the interval could sometimes be disadvantages. Now, the third method is a stratified random sampling method, where instead of just doing simple random sampling, what we do is we divide the population into identified strata on the basis of some variables that you are wanting to use. For example, if you can use demographics, you can use characteristics that I define the situation. In Mohan's case, for example, we can use the stratification by saying people who are already using organic food or people who are not using. So these are the two strata. So recognizing that the target market might not be homogeneous, this particular approach utilizes the division of population into strata based on the characteristic that could influence purchase decision. So people could be value conscious, they could be health conscious, they could be environmental conscious, and therefore based on these we can then divide people into these strata. So once you define the strata, a random sample is proportionately drawn from each. That means if in the population these three kind of people are distributed in the sample in the proportion of 20, 20, 60, then in the same proportion, we draw random samples from each of the strata. Therefore, we identify the relevant strata into this Mohan's target market. For example, health conscious consumers, families with young children who are seeking nutrition options, or budget conscious shoppers who are swayed by value proposition. So if you are just taking these three strata, we then get information on what is the proportion of each strata within the overall population. This information is crucial. We use either the local demographic data or marketing research reports to identify that proportion. Using this input, we calculate the appropriate sample size for each stratum, because we'll be using them in the proportion of the population proportion itself. And then we undertake a random sampling within each subgroup to look at the number of people that we want to select from each subgroup. Now, the main advantage of this is that we get a very deep and a nuanced understanding of relevant behavior. For example, how do people who are health conscious behave with respect to organic vegetables, as opposed to people who have young children and would like to worry about their health and the kind of overall long-term health that the children would be getting if they're only using organic food, as opposed to people who are stumped by the high prices of organic food, and because they essentially value conscious, this becomes a barrier. So we try to study behavior of people in each random sample, and this then becomes the key advantage, that you have a very nuanced understanding of how each substratum or how is subsegment, which we call the strata here, behaves, and how is this behavior different from each other. Therefore, what is it that you can draw as insights from this sample? Of course, here again, the major drawback is the additional effort that is required to define relevant strata and the calculation of population proportions. The next method that we'd like to talk about is cluster sampling, which is usually utilized only when you have a distributed market situation. For example, your market is distributed into different neighborhoods or over different cities and so on. So this is when you are looking at a distributed and dispersed market situation. It's a practical and cost-efficient approach to apply. The target area could be a city or a region. It could therefore be divided into smaller clusters like neighborhoods or pin codes or so on. Let's say the whole city has been divided into 500 or 200 clusters. Now, out of this 200, you then randomly choose clusters so that they can represent the entire population. So, clusters are first identified, and then you select randomly some clusters which you can then investigate deeper. So, if you are looking at Mohan's case for implementation, we divide the area Mohan serves into different geographical clusters, either by using neighborhood boundaries or pin codes or so on. And then you draw a random sample from these clusters using a random number generator. So every third cluster, every fifth cluster, depending upon what is the generators that you're using, you then draw this number. And then for each cluster, because each cluster represents your population per se, so you survey all potential customers within that chosen cluster. It's generally because we're looking at distributed market situation here. A cluster sampling is often less expensive and much easier to implement. However, the only disadvantage is that if you have missed out on certain cluster in the random selection, may contain potential customers, and because you're studying all potential customers only within a cluster, you may actually miss out on those potential customers, especially if they are displaying heterogeneous behavior. Now, if we want to sum up this session, we began by identifying basic sampling concepts and also try to understand why do we need sampling at all. I mean, with conducting research, we could do with the study of the whole population. However, extra time, extra cost, and the inconvenience of covering very, very large population, managing data, managing quality of data, make it difficult for people to study the entire population. Therefore, sampling is a cost-effective, time-efficient manner of conducting a marketing research study. I must also outline to you here that mostly when we are doing sampling design or we're trying to select samples, we are actually looking for quantitative data, and we collect this data so that we can draw insights from them. So samples are generally drawn when we are looking at quantitative analysis, quantitative information and data on behavioral inputs. We then in this session looked at what are the different kind of sampling designs, dividing them over probabilistic and non-probabilistic sampling designs, and explaining that in probability designs, all elements have a known chance of getting included into the sample. We then put our focus only on probability sampling designs and tried to cover 4 different types of sampling designs: simple random sampling, systematic sampling, stratified random sampling, and cluster sampling. We again used Mohan's caselet to illustrate how each of these could actually be applied, and also briefly looked at what are the advantages and disadvantages of each of these sampling techniques. We will follow this session by a sampling design 2 session, where we will discuss the non-probability sampling designs. I hope the inputs in this session were useful to you, and that you will be able to make use of them in your own marketing research activities. Thank you very much.